Hello, my name is Mia Whithoff, and this is my Physics 2022-12 Lab 1. So to introduce, the purpose of this lab is to determine how much excess charge is in one piece of charged tape. So in order to do this lab, we use two physics concepts, Coulomb's law, which is F equals Coulomb's constant times charge 1 times charge 2, all divided by r, the radius squared. This determines the force of an electric field on an object from two different charges. The next concept we used is Newton's second law, which describes the force on an object using its mass and acceleration. Two models are shown here of the experiment, the one on the left being the tape experimental model of how the tape was positioned and what happened during the experiment. The one on the right models the two pieces of tape as point charges and shows the forces acting on the upper piece of tape, tape B, shown in the left-hand model. So for the experiment, the initial conditions of the tape were 0.2 meters, the length of the tape. The mass of the tape was 0.0031 grams, and the distance between the two tapes was 0.0269 meters. And that is the distance at which the upper tape started to move in reaction to the lower tape within the proximity of it. So the code for the computer model is shown here. Basically, what I did is modeled the two pieces of tape as spheres or point charges, and then I calculated the force of gravity shown by the green arrow and the force of the electric field from the bottom piece of tape and the orange arrow. And then the program calculates the excess charge on the tape. So for this experiment, we got 5.48 times 10 to the negative 8. So the procedures for the lab are the lab setup that we did is shown here in this photo. You lay a 20 centimeter piece of tape over another piece of tape on a flat surface. You quickly rip off the top piece of tape, and this creates a charged piece of tape. Then you suspend that tape between two supports. We use books in this photo, seen there, and you create another charged piece of tape and hold it underneath the suspended tape, and you measure the distance at which the suspended tape starts to retract from the tape that you are holding. So the results of this experiment, we observed that the two electrically charged pieces of tape repelled each other. Tape attracts to another person's hand, and it also attracts to neutral objects, such as a book, as what we tried in this experiment. Our calculations, we found the gravitational force on our tape to be negative 0.373 newtons and the electric force to be 0.0373 newtons positive, and found these forces using Newton's second law, and we found an excess charge using Coulomb's law and found that to be 5.48186 times 10 to the negative 8. There may have been errors in this experiment due to loss of charge, due to the interacting with the tape in your hand. And this will decharge the tape a little bit and may lead to errors in the experiment of the distance between them. So the final question is, what if electrons had a positive charge and protons had a negative charge? So if protons and electrons switched in their charge, they would actually have the results of this experiment would be the exact same. This is due to the charges, to opposite charges repelling each other and opposite charges attracting each other and like charges repelling each other. Even if the charges of electrons and protons were switched, they would still be either like or opposite charges, so they would still behave in the same way as they did during this experiment. The other question, why is it important to handle the charge tapes as little as possible? This is due to the charge of the tape dissipating into the person's hand as they interact with the surface of it. So it's very important to interact with it as little as possible, and that prevents errors in the experiment. So that is my lab. Thank you for watching.